We're going to talk about difference of squares and perfect square trinomial factoring today. So the first one we're going to talk about is a difference of squares, and that is if you have a square minus b square, it equals to a plus b, a minus b. So here are the factors. So when you have a difference of squares, one of the things you're looking for is your exponents have to be even, and all the numbers in your difference of squares have to be perfect squares, like 1, 4, 9, 16, 25, so on and so forth. Okay, now the sum of squares is not factorable, so always look for that. The sum of squares is prime over the real number system. All right, so any time, we've talked about this before in previous lessons, that anytime you factor, you always just look for the greatest common factor first before you try any other method for factoring. All right, so this binomial factor in number 1, if you notice, these are what you call conjugates. And conjugates are a plus b and a minus b. And that will always produce a square minus b square. Now, I'm going to completely FOIL this and show you how the two middle terms, when you FOIL it, the O and the I, if you are familiar with the FOIL process, the O and the I will always cancel because they will be opposite of each other. So if I FOIL, I get 4x squared, then I get positive 6x, then I get negative 6x, and see how those two terms will cancel, and negative 9. So I end up with 4x squared minus 9. Okay, now what we're going to do is I'm going to give you this, and you're going to have to produce the factors. Okay, so our directions for 2 through 7 say to factor completely. So the first thing we need to do is look for a greatest common factor. Y squared and 49 do not have a common factor other than 1. Now, my exponent is even, it's a 2. 49 is a perfect square number, 7 times 7, and I am subtracting those two. So I do have my a squared minus b squared scenario. Now, when that is the case, I need to break up those factors. So split your y squared, y times y, 7 times 7, and 1 plus and minus. If you want to put the minus in the first parentheses and the plus in the second, that is completely okay. It does not matter as long as you have opposite signs in your parentheses and that your two binomial factors are conjugates with respect to each other. Number 3, all the numbers 9 and 25 are perfect squares. All the exponents are even, they're divisible by 2, and I am subtracting. So I'm going to break this up. 3s, 3s. If you multiply these two together, you go back to 9s squared. Then I'm going to break up my 25, so that's 5t and 5t. And I get 1 plus and 1 minus. So my factors have to be conjugates of each other. Now in number 4, we do have a greatest common factor. So I'm going to take out the 2. When I do that, I end up with 25 minus d squared. So I did not begin with a difference of squares, but I ended up with 1 once I took the greatest common factor out. So that would be, the 5 goes first because the 25 is first. Your d's go last, and then 1 plus and 1 minus. Notice I still have that greatest common factor 2 out in front. You always keep that common factor as part of your answers. Now, number 5 does have 2 variables, just like number 3 did, but all those variables are in that front term. So 64 and 1 are both perfect squares. All my exponents are even, and I am subtracting. So I'm going to split that 64. 8xy and 8xy. 8 times 8 is 64. Then I'm going to break up my 1. 1 is a perfect square. 1 squared is 1, so it is considered perfect. I need 1 plus and 1 minus, and that would be my final factors for my conjugate factors for that difference of squares. Now, number 6 is special, so kind of put an asterisk by it, because in this one, we are going to have to do what I call a double difference of squares. So we're going to factor it once, and then we're going to have to factor it again. So when I look here, my exponent is even. It's a 4. 4 is an even number. 81 is a perfect square, 9 times 9. So I'm going to break that into h squared and 9, 1 plus, 1 minus. Now, I told you we were going to have to factor twice, because when I broke up that original problem into its conjugate factors, one of my conjugate factors just so happened to be a difference of squares. This one is not. We cannot factor a sum of squares. So we're going to leave h squared plus 9 alone. And then I'm going to break up h squared minus 9 into its conjugate factors of h plus 3 and h minus 3. So when your exponent is bigger than a 2, you may end up having to factor a little bit more, okay? And our exponent was bigger than a 2. Sometimes you do, sometimes you don't. So just pay attention to what factors you get from the original problem. This one is prime. Now, yes, both 4 and 9 are perfect square. 2 times 2, 3 times 3. Our exponent is even. But since this is a sum, you cannot factor the sum of squares over the real set of numbers. So that is a prime problem. You cannot break that up. Now, the next two examples involve factor by grouping. And once you get your groups, then one of your groups ends up being a difference of squares. So you're going to have to double factor in this problem as well. So remember, factor by grouping is 4 terms or more. And we have 4 terms. Now, when I look at that, I do not see a GCF. I can't take anything out of all 4 terms. So I group the first 2, I group the last 2. Out of the first group, I can take out an x squared. The reduced terms that go back are x minus 3. In the second group, I am going to take out the negative with the 4, because that leading number is negative 4. And then that gives me x minus 3 as a group. So this is the first factoring of by using factor by grouping. Now, one of my factors just so happens to be a difference of squares. And I mentioned earlier, when you have an exponent that is bigger than a 2, sometimes you may have to factor something twice using different methods. So in this one, I am going to break down my x squared minus 4, because it is a difference of squares. So x plus 2 and x minus 2. 2 squared is 4. 2 times 2 is 4. So that's why I broke that down further. We're going to do the same thing with number 9. I do not have a greatest common factor, so I am going to group the first 2 and the last 2 together. Out of the first group, I can take out an x squared. That leaves me with y squared minus 1. Out of the second group, I am going to take out a positive y squared, and that leaves me with y squared minus 1. So my groups are y squared minus 1 and x squared plus y squared. Now, I can factor this one. It is a difference of squares. So y plus 1, y minus 1. I cannot factor the second one because it's a sum of squares. So I had to use 2 different methods for factoring that particular problem. I had to do factor by grouping, and then difference of squares. So you're not always going to be able to do just one method for factoring. So you have to be very, very careful with that. Now, perfect square trinomial factoring, you can try to learn the trick if you want, or you can just factor it the way we did in the previous section. Okay, so this right here, check for perfect square trinomial. Determine whether the first and the third terms are both perfect squares and have positive coefficients. Okay, if this is the case, identify A and B, and then determine if the middle term equals to 2AB or negative 2AB. So when I multiply this in number 10, the 3x minus 4, that would be 3x minus 4 twice. That's what that exponent 2 means. And then when I FOIL it, I get 9x squared. I get negative 12x. Then I get negative 12x. And then I get positive 16. Now this, when I clean it up, 9x squared minus 24x plus 16. This is a perfect square trinomial because I took one binomial, I squared it, and that's the outcome. So what we're going to do is we're going to go from here back to those factors that are squared. So how you do this is, it says determine whether your first term, I don't know why it won't leave it highlighted, but y'all can see where I'm trying to highlight. Determine if your first term is a perfect square, and it is. That would be 3x squared. Your last term is also a perfect square, 4 squared. So now I need this middle term to be 2 times 3x times 4. And it is, because 6x times 4 gives me 24x. So this is a perfect square trinomial. Once I get that, I write down my 3x, my 4 squared. Okay. Now, in the second, or this number 11 example, I apologize for calling it the second example, it wants to know which one is a perfect square trinomial. So this is x squared, this is 3 squared, and this should be 2 times x times 3. And it is. Here, same thing. I have x squared, I have 3 squared, but this does not equal to 2 times x times 3. So this is my perfect square trinomial, and this one is not. Now that doesn't mean that you can't factor the x squared plus 9 or 10x plus 9. It just doesn't come into the perfect square factors. So when I factor this, I just put x plus 3 squared. I use the plus sign because that middle term is positive. If that middle term b was negative, then it would have been x minus 3 squared. Okay, so we just factored that first part. All right, so look for patterns. So to factor completely, remember they always tell you this because they're reminding you to take out the greatest common factor first. So my first term is a squared. My last term is 8. Is my middle term 2 times a times 8? And it is. So I come over here and I put 2 minus 8 squared. That's how you factor a perfect square trinomial. All right, and number 13, when I look across this problem, I do not see a greatest common factor. So my first term is a 3x squared. My last term is a 5 squared. This middle term should be 2 times 3x times 5. And that is a 30x. So my factors are 3x plus 5 squared. I used a plus because that middle term is positive. All right, for number 14, we do not have the terms in order, so I need to drop that 50 to the back. So 2d squared minus 20d plus 50. Now I do have a greatest common factor of 2. All my numbers are divisible by 2, so I'm going to pull that 2 out and put the reduced trinomial back. So If I can go any further, my final answer should look like this. If I cannot go any further, then this would be my final answer, but at least I have to try. So I'm going to focus on the d squared minus 10d plus 25. I have d squared as my first term. I have 5 squared as my second term. And the middle term should be 2 times d times 5, which it is. 2 times d times 5 is 10. So I'm going to have d minus 5 and d minus 5. Or I'm simply going to write it as d minus 5 squared. In number 15, I do not have a common factor. So my first term is a 3x squared. My last term is y squared. And the number in the middle is 2 times 3x times y. So that does equal to 6xy. So my factors are 3x minus y squared, since it does fit the pattern for a perfect square trinomial. All right, number 16. If I take my 2x, sorry about that, my 2x and my 5. This number in the middle does not equal to 2 times everything else. So when I do this, that would be 2 times 2x times 5, which is actually 20x. It's not 25. So this is not a perfect square trinomial. Now, just because it's not a perfect square trinomial doesn't mean that I can't factor it. So we are going to factor it using the AC factor by grouping method, or you can do trial and error. So I'm going to multiply 4 and 25. That gives me 100. Factors of 100 that add up to 25, or I'm going to do trial and error. I apologize because I remember that most of you prefer trial and error. I apologize. All right, so we're going to break this one down. 1x times 4x, or 2x times 2x. And then, of course, here I've got 1 times 25 as the factors and 5 times 5. So I need to come up with my factors. So I'm going to do x and 4x. So I'm going to use these factors first. There are no negatives in the problem, none. So I can't put any negatives in my factors. So I'm going to put 1 and 25 here. Now remember, you're doing the outsides and the insides, and you want it to equal to 25. So 25x plus 4x does not equal to 25x. So I'm going to take that out, and I'm going to put the 5's in. And I'm going to try again. That would be 4x. I'm sorry, that would not be 4x. I apologize. That would be 5x plus 20. And that does give me 25x. So these are my factors. Notice they are not exactly the same. I have an x plus 5 and a 4x plus 5. So just because your first number and your last numbers, or your first term, I should say, and your last term are perfect squares, that doesn't mean that they are always perfect square trinomials. All right, number 17. Not in the right order, so we're going to rewrite this in order. We're going to drop that 12 to the back. So it stays positive 12 on the end. I do have a common factor of 3. That leaves me with 9s squared minus 12s plus 4. Now, if I can factor it further, I'm going to try, but my focus is going to be right here for the moment because my 3 is already part of my answer. So if I break this down, that's 3s squared. I break this down, that's 2 squared. And the number in the middle should be 2 times 3s times 2. And that does give me 12s. So that means What's in the box, the 9s squared minus 12s plus 4, is a perfect square trinomial. So I'm going to put my 3, my greatest common factor, and then I'm going to put my 3s minus 2 squared. I'm using a minus because that b term is negative. So that would be my final answer. Now, I do not think you're going to run across number 18 or number 19, but just to show you that these are different squares. This is a square. The whole group is considered a square. So when I factor that, I'm going to get 3z plus 1 twice, 3z plus 1, and then I get a plus 9 and a minus 9. So the 3z got split and the 81 got split. When I add together, I get 3z plus 10. And when I add my negative 9 and my 1, I get 3z minus 8. And those would be the factors for number 18. Same thing with number 25. I can break that 25 up to 5 and 5. I need 1 plus x minus 3, and I need 1 minus x minus 3. Now notice I put this one in parentheses because I'm going to have to distribute that negative to that group. So I get x plus 2 here, 5 and negative 3 add up to 2. Here I have to do a little more work, so that's 5 minus x plus 3. So my factors are going to be my x plus 2, and then I get negative x minus, or negative x plus 8, or 8 minus x, whichever way you want to write it. So I hope that helps with difference of squares and perfect square trinomials. If not, please contact me and we'll work through some more.